unable to attend, having been selected through the Mayutic Texas candidate process, vetted, prepared, and in conflict with the timing. Asghar Sahin of Columbia University consented, asked, desired his work to be presented to the Congress on the Future of Engineering Software. I'm presenting Asghar's work. Survival of trees relies on water being transported from the ground high into the tree. They do this with seemingly effortless energy, with an extremely reliable system. It doesn't really seem to fail. And it does it with a reliability, but with no pump. How does it do it? The mechanism is evaporation. And for some reason, this principle has obscured our societal observation. And we're not able to see that evaporation is a powerful force that we haven't used yet. The serendipity, the journey of serendipity that Asghar and his team have traveled started with their interest in finding a material that could be made from a biological microbe, specifically the spore. Now, the spore is a living cell that doesn't use food. And it can last for a very long time. It's very stable, very redundant. And the most phenomenal thing about it is that its structure, it has a very, very rigid cell wall. And the rigidity of that cell wall is what was very interesting to Asghar and his team. Now, what made it even more interesting is that the rigidity of that cell changes when moisture occurs. Water comes in and the cell grows. When the humidity goes down, that structure of the cell retracts. And that is really interesting, but only if you can measure it. And so they did. It turns out that a 0.5 kilogram of dried spores can lift an automobile about 1 meter with nothing but moisture added. Now, this is pretty cool, but the challenge, the question, the curiosity, does it have an application? How can you capture it? How can you hold it? Their answer? Suspended in a glue, put it on a substrate, and let the cells go to work. By work, I mean bending a membrane substrate. And the work done then needed to be captured. So bending a substrate, but that still doesn't quite get to the point because humidity changes slowly. Check your barometer. And we need to get work fast. So they said, where can we get humidity? Where can we get energy? We have a lot of evaporating. We'll use bodies of water. And the question was, the curiosity was, could we somehow capture the evaporation coming off of a surface with shutter mechanisms that modulate the humidity within the cell, within this power generation, within this evaporation engine, if you will? Well, so they went to work. It turns out that if you take and you put a pattern of these cells in a certain way on this filament, you can get a 4x, or Asghar and his team were able to get a quadrupling of length. In other words, it's short, it's long, it's short, 4x. And that's significant in the case of almost like a muscle. And so when you put a lot of them together, you get these fibers that are able to stack together. And when they stack together, they generate force. And in this case, they are able to lift the plastic up and down as the humidity is changing. Now, the engine. Couple these with the shutters. The humidity inside and out is changing. The shutters are opening up and down. So what? Well, if you take the evaporative energy and compare it to the wind and the solar energy available, there's more evaporative energy to capture than just wind and solar. An additional thought, you'll save the water too because you'll slow the evaporation process. Oh, and one other thing. Because the water is storing the energy, you don't need batteries on the as you connect it to an electric grid. And when they did the calculation of scale, they found out that the mechanism deployed at scale could actually keep up with electric demands. This is evaporation, mechanical operation of energy storage, on-demand power, water savings, all from a biological material. And just to say that there's a lot of things you could do with it, here's a mechanism that's using flexure membranes, changing the CG, driving a car. We've got an evaporation-driven vehicle. I encourage you to reach out to Oscar, collaborate with him, and let's start doing some transformation using evaporation. Thanks so much.